Okay, solve this exponential equation. We could log both sides, but notice how 81 is a power of 3. Let's write this as 3 to the x plus 4 equals 3 to the 4th power. Now we see that both sides have a base of 3, so we can set the exponents equal to each other. X plus 4 equals 4. Let's subtract 4 on both sides and get x equals 0. And that becomes our solution set. Okay, now that was 3 to the x plus 4 equals 81. Let's change this now. 3 to the x plus 4 equals 85. Our answer should be just a little bit bigger than 0. We cannot write an 85 this time as a power of 3, so we're forced to log each side. Logging the left brings the x plus 4 down times the log of 3 equals the log of 85. Now let's divide off that log. That will give us x plus 4 by itself on the left equals the log of 85 divided by the log of 3. And then we can isolate the x by itself, subtract 4 on each side, have the log of 85 divided by the log of 3 minus 4. So, an exact solution is just what we have right there. Log of 85 divided by the log of 3 minus 4. A decimal approximation, rounded to 4 decimal places as we usually do, would be x is approximately 0.0331. And notice we said our answer was going to be just a little bit more than 0, and that's what we have here. Let's review this logarithmic equation. We've got logs on each side, but we don't want that minus 1 with the logs. So I'm going to bring that minus 1 to the other side and bring the log from the right over to the left. We now have on the left the log of x plus the log of x minus 9 equals 1 on the right. We now have addition between our two logs, which turns into multiplication. So we now have log of x squared minus 9x equals 1. We want to get rid of the word log, so we're going to write in the understood base of 10 and convert this to an exponential equation instead of a logarithmic equation. We have 10 to the first equals x squared minus 9x. That is a quadratic equation, and we can subtract 10 on each side. X squared minus 9x minus 10. This is now going to be factorable. That's going to give us x minus 10 times x plus 1, and we will have solutions of 10 or negative 1. However, when we substitute that negative 1 back in, we get the log of negative 1. Even that 10 is almost not safe. 10 minus 9 is 1 and it's safe, but had we had an 8, that would not have worked. So as it is, the negative 1 will have to be crossed off, and our solution set will only contain 10. Moving on. We now have another logarithmic equation. Let's bring this natural log of x minus 2 to the left. Write this as the natural log of 21 minus the natural log of x minus 2 equals 1. When we have subtraction between our logs, we can write this as a quotient. The natural log of 21 over x minus 2 is equal to 1. We have a base of e understood to be there, so we can change this to an exponential equation. We get e to the first equals 21 over x minus 2. Okay, we might be getting out of your comfort zone here a little bit, but that's okay. We're going to stretch a little bit. Let's put that as e over 1. Let's cross multiply. Cross multiplying on one diagonal gives you e times x minus 2e equals 21 on the other diagonal. Now, e is not a variable. E is a number. So our only variable here is x, which we're going to solve for. So let's bring the 2e to the right, have ex is equal to, and I'm going to write this as 2e plus 21. And then we're going to divide through by e. Now there's a couple ways we can do this. We can either divide the whole side or just each term individually, which is what I'm going to do. And we're going to have x is equal to 2 plus 21 eighths. That's kind of fun to say, isn't it? So now we've got a solution set of 2 plus 21 eighths. And if we substitute that into the calculator, which I'm going to do very quickly, if you substitute that back into your calculator, you get that x is approximately 9.7255.